or is it like कि until given ये online वालों के लिए कि given an option it is better to sit at home. अभी 4-5 भाग के गए है ना, अगर वो unmute करके बैठे रहो ना attendance मिल जाती है, यहाँ पे you have to pay attention. चलो anyways, this is just a matter of time. वो पुराना टाइम तो वापस आएगा ही, ऐसा तो है नहीं, right? So beginning with let me again just flip through what we did in the previous session, because as I mentioned we'll be completing with module 3 today. अगर इसमें कुछ issue आता है flip to the slides, you can ask me again. You A division has already implemented one problem using a greedy technique, right? C division has to implement. And we'll be completing this in the first hour. I assume that you people must have practiced the questions of the portion covered. The extra के questions मैं आज दूंगी. So combining all these 4 problems, you have to submit end of this week on GCR the problems in the group. ठीक है? And MCQ will be conducted today in the session in the break spot. Okay, so there are only 10 questions from this module. You have to attempt them in the break time. And then we will begin with dynamic, because again next week Friday को session नहीं होगा, और उसके बाद again you have your second ISA. So the portion is module 3 and 4. So I'll begin with module 4 today, and next week we'll complete module 4. Okay. So when we had began with greedy method, so first of all we saw कि greedy क्या है. Similar concept अभी dynamic programming में भी आ जाएगा. We will be picking optimization problems only. So that is something which has to be maximized or minimized. So what you have to remember is एक optimization function बनाना होता है, and this is to be maximized or minimized given a set of constraints depending on the chosen problem. Because this is a first session offline, I'll close the door at sharp 12 from next time onwards, because it disturbs the class. And those who are not wearing masks, they are not allowed in the class. Those who are not wearing iCards, they are not allowed in the classroom next session. And again, I should mention, offline start हुआ है, but again the syllabus is to be completed in 2 hours instead of the 4 hours. So the pattern will remain the same. It is not possible for any faculty to watch how you are practicing on your tables if you are writing. अभी एक वीडियो बहुत वायरल हुआ, you all must have seen, which says people say that it is MEC 16 batch का बनाया हुआ ही वीडियो है. You must have seen कि students come for offline exam, हाथ नहीं चल रहा, कुछ लिखा नहीं जा रहा. Then they are in a habit of asking each other. नहीं देखा? तुम लोग तक नहीं आया? तुम लोग के पास से पहले आते हैं?
नहीं आया मैम.
अच्छा, उधर भी नहीं आया. ठीक है, तो I'll share with anyone later. Okay, so after that what we had seen is the problem with greedy is that they do not yield optimal solutions always, because the name greedy. That is why we will look at the other technique, that is dynamic programming today, which guarantees optimality. So these were the problems. 3 problems we have already seen last turn. एक problem पे 2 algorithms we have seen. So total we have seen 4 algorithms last turn, and the last one we will be seeing today. So knapsack, any one of you will like to explain what is a knapsack? मन में नहीं बोलना है. It should be audible to others, na? And there should be a difference between offline and online. वहाँ पे तो unmute करता ही नहीं था कोई भी. Any one of you would like to explain this knapsack problem? को marking अभी भी वही है. I have this. I am noting out the roll numbers. Anyone in online mode would like to answer? Maximize the profit within the given capacity. Anything is missing out? Roll number? Okay. He said maximize the profit given the capacity of the knapsack. That is the objective. Using? नहीं, वो तो method हुआ. I am asking what the problem is. Problem का solution can different methods could be there, and we are trying to do it in the best possible manner. So for that we are studying a technique. I only ask what the problem is. So the problem is that is a knapsack is given which has a capacity, and you have to optimally fill the knapsack so that maximum profit is obtained. And we also have to describe the problem. There are certain number of items, each having a certain weight and having a certain profit which is earned by when we put the knapsack into the item into the bag. Last roll number, phone यहाँ रख दो. मैंने बोला ना offline I started. इसीलिए यहाँ से उठ के वहाँ गई थी. Okay, then we saw the variants of which fractional knapsack हमने GD में किया है. 01 knapsack will be covering in dynamic programming. So please students get confused when it is asked in the question without reading it properly कि कौन सा knapsack पूछा है, कौन से technique से पूछा है. If we write the reverse, we don't fetch marks. So this is how we mathematically write it. And then we have seen this example, and you were asked to solve the algorithm, the complexity, and raise your hand. How many of you have tried? C13 है.
Ma'am, what?
ये जो problems है ना सामने, how many of you have tried? I had asked you to keep solving. Anyone online has tried?
Yes, ma'am.
Is that? Who said yes? Yes. Okay, then we had moved to the second problem. So this is, you must be able to define what a spanning tree is. So now because A division is already done with the experiment, now you must be clear what the definition is. और अगर definition दिमाग में होती है, then we know what solution is required, right? To solve this problem, we had seen two approaches. That is the Kruskal's. The methodology is you're sorting all the edges in the increasing order using the best sorting algorithm. And then we are building a forest each time so that in the end we have all the vertices covered, all the edges have been checked out. So that is the difference in Kruskal working and then when we move to Prim's. Okay, again in Kruskal's there were two questions on the slide. How many of you tried? C23 A3.
Ma'am, I did for knapsack. Kruskal का बाकी है.
मैं roll number बोलना पड़ेगा ना. I'm not opening the screen.
Ma'am, save roll number 31. Ma'am, 31.
Always remember, you always remember that this method say you are solving, that is also important. Otherwise, you are not getting marks. So you are stating it in the way of the algorithm, this way, not as it was in the previous slide, depending on the marks. अगर कम marks का है या MCQ kind question है, then you can solve any ways and relate to the answer. Otherwise, the algorithm is to be followed. In the assignment, algorithm is to be followed. Then we had moved to, and you always remember Kruskal's में you are not stopping the iterations जब ये सारे vertices visit हो जाएंगे, because again you are using on marks. You have to show all the remaining edges even if all the vertices have been visited and show that these are rejected due to cycle formation. Then we had moved to prims. So in prims, again, the methodology differs. You can begin with any source vertex. That is not a constraint. But agar labeling hai, we begin with A or 1. That is not a constraint. And you try to build a single tree. So in that case, again, when we follow the algorithm, you have to keep track of how many data structures, how many variables you are going to use. And accordingly, the complexity becomes n square because for each vertex, you are checking the link with every other to find the near one. So accordingly, when you're solving prims, any of the examples on the slide or any other examples which you practice, please follow the algorithm. So how many of you have tried executing prims, solving prims manually? तुम लोग को पता है ना कि फर्स्ट ईयर का ME and FE both are exams are going to happen offline. ये भी इंफॉर्मेशन नहीं आई होगी ना, तभी ऐसा इतने की स्ट्रेंथ में 1 or 2 are saying कि we have practice. So within a month's time, things might change for you people also, right? So this is all about prims, the examples which are not to be solved in this manner. Exam may definitely such big graphs will not come. We'll try to put according to the marks and according to the time, smaller graphs. हाँ, बिल्कुल. अभी ठीक है. Then we have moved to this problem, job sequencing में deadline is wherein there are some jobs, there are machines, and there is a deadline कि job को कब तक complete करना है. We have to sequence these jobs onto the machine. So you cannot put the sequence such that the job misses its deadline. So there is no sense of scheduling the job. So you'll not be able to perform the task. And again, you have to maximize the profit earned by scheduling these jobs onto the machine. So we check out all the possible combinations. So in a tabular manner, you'll have to illustrate all the possible combinations. Here combinations of 3 were not possible, but as I mentioned, kahan par combination of 3 are possible, in what kind of input? Anyone answer? My question is, over here combinations of 3 we have not chosen. We have chosen single jobs. We have chosen combination of 2 jobs. So why couldn't we have taken a combination of 1 2 3 1 3 4? We could not have chosen the combination of 2 4 and 3 because 2 अगर पहले schedule करोगे in the sequence, 4 will not be able to schedule 4, right? So वैसा possibility कब होगी when I can form 3 का pairs? When there are 3 different deadlines. यहाँ पर only 2 unique deadlines are there. So such example was there over here. Now how many of you have tried these? Anyone online has tried problems with job sequencing with deadlines? No. So let us begin with what we have to cover today. Again, because C division has not implemented practical on greedy, they can also choose these extra algorithms. So now what we consider is the same kind of graphs will continue when we are dealing with dynamic programming. So please pay attention. This is a weighted graph. Adding to the connection again, there are some weights of cost. So this is basically talking about a flight route graph, wherein the edge represents the distance in miles between the endpoint airports. such real life data can also be given, or some dummy data wherein the graph is there and there are some values between the connections. So the weights on the edge may represent any distance, any cost, etc. So this is what we'll be using today, that is Dijkstra's algorithm to find shortest path from a given source to every other node in the graph. इसके लिए इसको बोलते हैं single source shortest path, right? Because the source is given and you have to find the shortest distance from the source to every other vertex, whether it is directly connected or not. And the applications are internet packet routing, flight reservation, driving directions, and there could be other applications as well. So again, objective हमारा क्या है? हमें minimum path find करना है between any two points. So now let us look at the algorithm. The graph is given to you. Please note this is not a matrix. This is an array which has been shown iteratively to you. So data structure जो use हो रहा है सिर्फ array है. हमने क्या store किया हुआ है? I have a source. From that source, what is the cost to every other node? Okay. So let us look at the first row of this matrix. The first row says, क्योंकि source दिया हुआ है, तो my visited vertex becomes the green one, that is 1. So 1 already visited it. 1 say what is the cost of every other node, that is written in the array. So in an increasing order for 2, 3, 4 and 5 and 6. Wherever connections are not there, the cost becomes infinite. So what should be the next step? The layman approach or the greedy approach? 1K nearing जो भी cost होगी, I should proceed there, right? So I will choose the next visited node as 3.
3.
So when I choose 3, will there be a change in the array because of the intermediate vertex 3? Does any cost reduce down further? I repeat the question. I said with inclusion of 3 as the next node visited and considering that as an intermediate node, will the cost change for any of the other nodes from the source vertex, that is 1? किसके लिए change होगा? Four की cost change होगी. Any other node? Someone answered, please be loud. 2 की cost change होगी. हाँ. 3 से 2 का तो connection भी नहीं है. I repeat the question. वो initial graph था, उस graph में the next visited vertex that we are including is 3. Via 3, is the cost changed of visiting to any other node from 1?
Ma'am, 4.
Yes.
Ma'am, via 3, the cost to reach 4 is 2. And from 1
4
it's
तो बताया. I am asking any other node is there? 4 की cost पहले 5 की अब 4 हो गई via 3. Any other node?
No, ma'am.
No other node? Okay. No other node? Still your people are not able to see this path 1 to 3 and 3 to 6. उधर 57 है और इधर इतने बैठे हुए हैं. You people are not able to see कि 6 की cost भी change होगी. 6 का अभी direct connection नहीं था, but now via 3 from the source we are able to reach to node 6. Yes. So accordingly, I'll make change to this array now, or my algorithm will make change to the array as ये 5 से 4 हो गई और वो infinity से 3 हो गई in the array, right? All of you? Okay. So now, which should be the next vertex that I should pick? Three तो हम already ले चुके हैं. 1 is visited, 3 is visited. either 6 or 2. जिसकी भी कॉस्ट मिनिमम होगी वो पिक करेंगे ना. I have the greed of doing this task at lesser cost, right? So randomly we'll pick either 2 or 6. Let us pick 2. So now 3 becomes visited and 2 becomes visited, as you can see in the graph. So accordingly you are whenever you are solving, you are listing array की क्या values populate हो रही है and the graph का structure क्या है. What next? 2 आया picture में, so any cost gets changed.
मैम 5th का
5 node की cost अभी तक it was not reachable from the source. Now it is reachable via 2 and the cost is. So as you can see in that array, the changes have been made. And which should be the next vertex that we have to pick? 6. क्योंकि पहले हमने जब 2 और 6 में decide किया था तो randomly we had chosen 1. 6 को choose करने से any of the costs are getting changed. 5 की cost अभी तक 7 थी and now it becomes 5 via 6. So the next node that we have to pick from cost 3, 2, 4, 7 and 3. कौन सी nodes अभी visited नहीं है? 4 and 5. So among 4 and 5 the cost which is lesser is of 4. So we choose the next vertex as 4. 4 के inclusion से any cost gets reduced further. Any distance gets reduced further. No. So there is no change in the array that gets visited, and last May we pick the last node as visited, and these are the diagrams you are expected to draw for each and every step because there was no space on that slide, so they have been mentioned explicitly. Vertex number 1 visit हुआ, उसके बाद because 2 was minimum, 3 was visited, then the next cost was 3 was minimum, so vertex 2 was visited. The next cost via 3 the change was made to cost of node 6, that was visited. And after that, via 3, a change was made to node 4 cost, that was visited, and finally node 5 was visited. Okay. So these configurations along with the array values that are changing at each step. So हमने problem देखी, क्या solve करना था? Single source से distance we have to find for every other node. How we solving it? We manually did that process. Now what is the next step? We'll look at the algorithm. How do we write it? So algorithm क्या बोल रहा है? Again, as I have mentioned, you have to write this algorithm, the parameters, the input, the output, initialization, then the main logic and the output. So this is single source shortest path algorithm, wherein I have the source vertex P, I have a cost matrix, I have a distance vector, the array which we were talking about. N is the number of nodes in the graph. Okay. Moving it, taking it ahead, S is a Boolean array which stores all the visited vertices. You could have a different implementation. अगर इससे कम data structure से काम चला सकते हो, it is up to you. So in S, we are just keeping track a Boolean array which vertices are visited. Now we have a for loop for what? What is happening in the for loop? Initialization. क्या क्या initialize करना है? Initially none of the vertices are visited, so that visited वाला जो array है that is initialized as 0, and there is a distance vector जो कि cost matrix से values लेगा, right? जो यहाँ पर array में किया था, we had initialized this distance vector from the cost matrix. या तो to solve, the graph would be given to you or the matrix would be given to you. So matrix से values कैसे आएंगी vector में? I have this matrix for this graph as 1 से 3, 1 से 2 में value है, 1 से 3 में है, 1 से 4 में है. And in the second row, I also have some values. In the third row, I have some values. Likewise, I have a 6 cross 6 का matrix. वहां से how are you picking the values in the cost? We are picking only from the source to every other node. So एक single row की value directly copy हो जाएगी in the vector, right? Because this is single source shortest path. You are given the source. You will only consider the first row if your source is 1 into the vector. Let us come back to the code. अच्छा, SP को 1 क्यों किया? P क्या है? P is my source. बस सबसे पहले हम उसको visit कर रहे हैं. So I am accordingly in the visited vector. I am making it as 1. Why is the distance P taken as 0? Source to source the distance is 0. ये पूरा is initialization step and now the main logic. अभी हमें कितने times iterate करना है? Why the loop is 2 to n minus 2? Vertex तो चला गया and last वाले को भी iterate करने की जरूरत नहीं है. So these are 2 n minus 2 vertices for which we have to iterate. What do I have to iterate? Distance vector में से हर बार minimum value को pick कर रहे थे, right? So that is why we are picking min from the distance over these iterations, and that is being chosen from among the unvisited vertices. इसी के लिए वो loop कितनी बार चल रहा है? n-2 times, because n-2 vertices are unvisited. Why are we making S of Q as 1? Replies from online. Q vector, Q में distance modify कर रहे हैं, तो Q visit हो रहा है. So now we are marking that as visited Boolean vector में 1/2. Now this is the update step. That is the main logic जहाँ पर हम cost को या distance को update करें. So distance कैसे update हो रही है? एक तो distance vector में distance है, दूसरी distance कहाँ से आ रही है? When I'm adding the distance with the cost. यही कर रहे थे अभी. यहाँ पर मेरी direct distances थी and what did we do? Let us say over here जहाँ पर infinity value है, so we took this from here. We are comparing this infinity and what were we comparing? ये 7 value कहाँ से आई थी? One, 2 and 5. So we computed from the cost matrix, right? So that is what it is written over here. We are comparing two things. एक तो distance of R, which is already there in your array, and the other thing is distance of Q, जो array से आएगी और उसमें add क्या कर रहे हैं? Cost between P and Q. Q is the vertex जो अभी visit किया and Q and T is my source. So I know the distance between P and Q. Now I am considering via this vertex is the cost minimized or not. If it is minimized, I'll update the cost. Where will I update the cost? In the distance. Yes or no? Online. People in the online meeting, have you understood?
Yes, ma'am.
Why is the complexity taken as n square? दो for loops है. We are trying to.
Ma'am, 2 for loops.
Yes. And there is a link given to you people for self study. In this link, again, depending on the implementation, अभी हमने implementation क्या लिया? HSLC matrix ली, right? So if we change the data structure, we are able to minimize the complexity that we'll discuss when we are doing dynamic programming with these techniques. So the reference is this, and from here you will be able to compute the complexities as V log V plus V. We have discussed this thing also with when we were evaluating. I was evaluating you people for Primson process. So Dijkstra's key complexity can also be V log V plus E, or we can also call this as N log N plus M. जहाँ पर M are the number of edges and N is the number of vertices. So again, a question for self practice. Again, the solution is given to you people, but the solution needs to be in the way in which I have discussed in the class. Okay. So again, this is a directed graph given to you. The source is given as V0 and you need to find the shortest path from V0 to every other vertex. So ये path दिया हुआ है and what are these vertices? First one is V0 to V2, second is V0 to V3, third is V0 to V1 and fourth is V0 to V4. So every other vertex in the graph, the final path and the final minimum cost is given. ठीक है? Second example, जैसा मैंने बोला, a real life example could be given of a map or of any touring, let us say traveling salesman. So again, in this case, map say matrix can be drawn. You could either be given the graph or you could also be given the matrix directly in the example. The size again can be reduced. So will this be a symmetric matrix or not? Yes or no? उसने तो yes बोल दिया. Anyone else? Any other reply? Will this matrix be symmetric? Yes. Another yes. This is a directed graph. So will the matrix be symmetric across a diagonal? It won't. That is why symmetric matrix is not given to you. Remaining whatever cells are empty, the value will be infinite. तुम लोग ऐसा समझो सबने मास्क लगाए हुआ है. Even if you are answering, you have to be loud enough for your voice to reach here, right? If you want the answer to reach to me. So again, the solution is given. You people can practice this. So यहाँ पे भी you people can see that we have started. Again, the source vertex is given to you as 6. So we have started from 6. And slowly we are including the vertices. We have started from 5. So next we are selecting vertex number 6 and 7, 4, 8, 3 and 2, and accordingly via that vertex, if the cost gets changed, we are updating the cost. So again, the 4 tasks were already shared with you people. I'm not delaying the deadline much because I am assuming that you must have distributed and solved till now. Every student must solve one question from each. That is mandatory, but even if you're performing in a group. So you must practice one for knapsack, one for crystal frame, JST and rigid stress. Okay. This was all on module 3. I am scheduling this FA. Those who are online, there will be 10 minutes for this FA, which is on GCR. On module 3. So 12:50, I'll close the link. Karthik, you've not been told that Your current photograph has to be put. Huh? Karthik,
And which
on
roll
Zoom.
number?
Sai Shivam. Thank you. So this is what we were talking about, principle of optimality mathematically. क्या बोल रहा है कि suppose we are to solve a problem and there are sequence of decisions that we have to take to reach from source to destination for solving that problem. If the sequence is optimal, then all the last k decisions must be optimal, which are intermediate in between the source and the destination. So if I have the shortest path between I and j, so if I have a shortest path between I and j, every path in between must be the shortest one, right? So I और j के बीच में I1, I2, I3 जितने भी path आ रहे connecting paths, all must be optimal. So these are the problems that we'll be seeing. Multi-stage graphs. How do we solve from source to destination if there are multiple stages? Single source shortest path, जो अभी देखा था in greedy. Again, people get confused what the question is being asked for. Single source shortest path was there in greedy as well as it is in dynamic. In greedy, the algorithm is Dijkstra's. In dynamic, we'll see that. All पे shortest path. All पे shortest path को single source को ही हम n times run करेंगे, then also the solution could be found, or you have a separate algorithm also for solving this problem. 0-1 knapsack, we have seen what a knapsack problem is. We have seen the fractional knapsack variant using greedy. We'll see 0-1 knapsack using dynamic. Traveling salesman problem and longest common subsequence. Again, these two were there earlier in the syllabus. Because of the vastness, they have not been included because पहले 4 lectures होते थे, अभी 3 lectures are there in the syllabus. So let me cover the first one, then you people can have 5-10 minutes. Multi-stage graph क्या बोल रहा है? This is a directed graph. इस directed graph के through the problem is being told to you कि अगर इसको greedy से solve करते तो क्या problem है? So if I'll apply the greedy method to this, तो सबसे पहले source पे which path will I pick? Path with cost 1, right? वहां से iterate किया to A, and then the next path that we are picking is with cost 2, and the next one that we are picking is 5. So applying greedy, the shortest path from S to T is 1 plus 2 plus 5, that is 8. So that was fine with that small graph. Now let us look at this graph and apply greedy method again. So S to A we will pick first, then A to D will pick, and then D to T will pick. This is a case wherein at the current state I am choosing the best possible solution, but this may not yield me to the globally optimum solution, right? So dynamic programming क्या करेगा? That we'll see when we are seeing the algorithm. But according to that, when we are choosing multi-stage graph, we have two techniques as forward approach, backward reasoning, and backward approach, forward reasoning. उससे चलेंगे. So we'll get to see the target pay connecting, which is the minimum vertex, and then we iterate backwards towards the source. So that is how we get the optimal minimum cost, that is none. So now let us look at these approaches one by one. This is the same graph that we are choosing. So in this graph, if I pick the first approach, जो क्या बोल रही है forward approach है. Forward approach का मतलब source से begin किया. So I have SA, SB and SC as my options, right? So currently I know the cost of SA, SB and SC, but I do not know A to T की cost, B to T की cost, F to T की cost, because मुझे नहीं पता कि इस stage में कौन सा path लेना. So that is why I am directly writing here. So the remaining as dotted because मुझे नहीं पता वहाँ पे cost कितनी लेनी है. Currently I know what is the cost. So accordingly I frame the equation as distance of S to T is minimum of 1 plus distance AT, 2 plus distance BT and 5 plus distance CT. This is fine. Now I have to compute this distance AT, distance BT and distance CT. So again AT के लिए if you look at the bottom of this slide, AT के लिए I have two paths, of which अभी मुझे पता है कि A to D की cost is 4 and A to E की cost is 11. So I'll write this as 4 plus DT. I do not know the distance from D to T. I do not know the distance from P to T, so I frame these as इनमें से जो भी minimum होगी. So we are moving forward, but we will populate these values backward and then get the original equation. वापस हम ST में आएंगे. So because हमारा 3 स्टेज का ग्राफ है, so directly I am getting this value dt. But let us say आगे भी stages होती है, तो this would iterate further. So direct dt cost we are putting there, that's 4 plus 18, 11 plus 30, whichever is minimum. That is कौन सा path लिया हमने? Via D or via E? Via D. Similarly, we'll do for BT and CT. So for BT, what happens is 9 plus DT, 5 plus ET and 16 plus FT. There are 3 options. Those are written there. And accordingly, the costs are written because वही हमारी last stage है. Which node is being picked? F is being picked. F is being picked there. F और E दोनों की cost same है. And then the last one, that is C to T. So if I look at the graph, CT के लिए क्या करेंगे? CT is 2 plus FT. We'll follow the same procedure. So CT is 2 plus FT single path आ रहा है. So that is why this is written here. 2 plus distance of FT, that is 4. अब क्या किया? मुझे minimum मिला CT से, BT से, and AT से. Now I'll put these values in the final equation. So the approach was forward, but the reasoning is being done backwards. This is understood? So this is multi-stage graph. Again, it depends how you're being asked and how you write. If you write the reverse way, marks are reduced. So this is backward reasoning, and the minimum cost we get is 9, and we also get the path जो initially मैंने इस slide में path बताया था, S, C, F, and T. Right? Now let us see the next approach, that is backward approach and forward reasoning. So what did I tell over here is S to T निकालने के लिए now I know DT, ET, and FT, and I do not know SD, SE, and SF. That is what is written there. The approach is backward and reasoning will happen in forward manner. तो मुझे क्या पता है? 18, 13 and 2 I am aware of. Target से just पहले की जो cost है, and before that I do not know the path because there are multiple paths. So that is why now I want to know SD की cost कितनी होगी, SE की कितनी होगी, SF की कितनी होगी in the same manner. So SD will be again 4 plus SA, 9 plus SB, right? इसमें से जो भी minimum होगा. Then similarly for SE, what will happen is I know 5, I know 11, and I know 16. So those are 5 and 11. Sorry. So those are put there, and I do not know SA and SB. ऐसा हो सकता था कि और भी stages हैं उसके पहले. Similarly for SF, what we are doing is SF के लिए I know 16 and 2. I do not know SB and SC. So accordingly, these equations are written. And then I need to know the values of these SA, SB, and SC. So those are, we are getting from the graph directly. We are putting the values back. And यहाँ से जो SC, SF और SD की values आएंगी, again we are putting back in this equation. So that is why again, now the reasoning becomes forward, whereas the approach was backward. Okay, so the last 3 lines, SD, SC, and SF values we are getting, we are putting the values again in SD equation and getting the cost. From both the ways, the cost will remain the same. It only depends on how you are being asked. This is fine. So it will remain fine only till the time you practice it once. Again, this is a question for you to practice. You will solve it in the same manner for both the approaches. Okay? Yes or no? Okay. So now you people can take a break of 10 minutes. So again, the applications remain the same. That is, if I have to statically or dynamically do the network routing. Last bench. आगे आ जाओ. Not you, the person sitting next to you. या फिर जो डिस्ट्रैक्ट कर रहा है उसको यहाँ पे रख दो. Robot motion planning. Earlier, people used to go to IIT for this robotics competitions. So again, these algorithms play a good role over there. And again, if you want to route or map for traffic. So Bellman-Ford algorithm क्या बोल रहा है? As I mentioned, Dijkstra's algorithm doesn't work when there are negative edges. Bellman-Ford is able to detect those negative cycles. Negative edge होगी तो क्या होगा? जब भी हम बार-बार iterate कर रहे हैं, the cost will go on reducing, right? You people are understanding this thing? So whenever the algorithm detects negative cycles, it returns false, or otherwise, if they are not there, then it will return the shortest path. So what are we doing over here is, again, there is a loop to initialize the graph. So if my V is the source, then the distance becomes 0. Why? Same reasoning so with this time source to source, the distance becomes 0. Otherwise, all of the distances are initialized as, and the predecessor concept is the parent of that node is initialized as 0 because all are disconnected, right? Then we need to iterate. So we are iterating number of vertices minus 1. Why? Because the source vertex has already been considered. And we are trying to find the path to every other vertex. So there are n minus 1 vertices remaining. And we are iterating over each edge. So that is why the complexity becomes V into E. Outer loop is running for capital V times, that is the number of vertices. And the inner loop is running for capital E times, that is the number of edges. And what are we initializing is edge में जो भी edge को हम pick कर रहे हैं, so we are initializing the source and the destination, the connecting vertices as U and V. So this is all about initialization. Now how do we update in this? So we call that procedure as relaxation procedure. And what is happening is again in the same way as we have done in the Dijkstra. If V dot distance is greater than U dot distance plus UV dot weight, that is via that particular connection, that is the edge UV. If we are getting a smaller path, we are updating the cost. And we are also modifying the predecessor. Because now this is a connecting vertex. So my predecessor of this node changes to U now. And we keep on doing this for all the edges in the graph. So we are relaxing the edge with each and every vertex. And whenever we get to see that the cost is going on reducing due to cycles, so this graph already automatically returns you that the graph has negative loops and returns false, that you will not be able to compute the minimum cost. So this we have discussed why is the complexity n into m, because there are n vertices and m edges. Now let us see the example for this. Initially, जो cost थी source vertex की कितनी रखी थी 0 and all other vertices की infinity. So that is just a symbol for infinity. You can write infinity in that place. And you can see in this graph that is given to you, there are negative weights as well, right? So what will be iterate? Algorithm देखा सबने. Next step पे graph में क्या changes आएंगे? क्या बोला था? एक vertex होगा, उस vertex से connecting the edges will be seen, and the parent will automatically be updated as per the minimum edge that is picked. So according to 6 and 7 that is traversed, my distance at t and y will change. t और y की distance कितनी हो जाएगी? जो भी cost है uv पर. So what is the cost at uv connecting s to t? 6. So At this vertex, the cost will become 6, and at the other vertex, the cost will become 7. Because the UV connecting edge was having weight as 7. What next? These are connecting edges we are seeing now. So what will be the cost at node X and Z? X पे कितनी आएगी? X पे 5 आएगी. The algorithm was saying we are looking at distance and weight. Distance vector node पे update हो रहा है. Distance vector is 0 and infinity. Then the distance vector became 0, 6, 7, infinity and infinity. And weight is a connecting edge. And we are checking for every edge in the graph, not only the one जो अभी current path consider कर. 11. फोर हो सर. 4. देखो यहाँ पे क्या बोल रहे हैं. For each edge UV we are considering, and UV is the edge in the graph. So when we are checking over here, you can see that 7 minus 3 x पे cos 4 जाएगी. Over here 7 minus 3, this becomes 4. And similarly, what about this? Six minus 4 at this edge, the cost becomes 2 over here. So at next step, we are picking these two UV edges, this and this, and accordingly the cost or the distance vector gets updated by 4 and 2 from infinity for x and z respectively. What next? T change होगा from 6 to 2. So again, if you look at this path, from 4 to minus 2, this again gets changed due to the negative weight edge. And there won't be any other change. Anything still gets changed? अभी जब t change हुआ तो t की नई वैल्यू की वजह से there will be a change at which node? Z. So Z value becomes now minus 1. Okay. So how are we traversing in this is we picked a source node. For source node से connecting UV edges we saw. Then we updated the distance vector for those connecting nodes. After that, again, the nodes that are now visited, we are again checking out all the possible UV edges. That are we updating the remaining vertices? So that is why there was a change in x and z respectively. After we are getting the new values for x and z, again we are checking for connecting UV edges. Are we updating any other vertex? So accordingly, there was a change in t. And after the new value of t was changed, we are again checking for all the connecting UV edges, whether the distance plus the edge t value is giving you a better cost. So accordingly, again, z was changed. So again, this is an example for you people to practice. Again, you can see that there are negative weight edges available over here. Again, you can see that initialization of every other node is infinity in the vector and sources. So her step पे graph draw होगा. Which path you are picking, the edges will be in a different color or you can highlight or you can put bold. जो vertex choose हो रही है वहाँ की cost change हो जाएगी and vector में cost change हो जाएगी. So please follow the steps and try to practice. Taking to the last topic for today. We could also have used Dijkstra's to solve this. So in Dijkstra's, we मैंने अभी बोला था कि when I am iterating the Dijkstra's for all pair shortest path for n times, the complexity becomes n square into n. जो लिंक दी थी geeks for geeks की, in that the complexity is n log n plus m, that is v log v plus e again, because we are using a heap over there, and when we multiply this, iterate over n times, the complexity becomes this. In Bellman-Ford, why is the complexity n square m? अभी जो किया था सिंगल सोर्स शॉर्टेस्ट पाथ का Bellman-Ford using dynamic programming, the complexity was how much? n into m. So when we iterate this for all pair shortest path, the complexity becomes n square m. So now you are seeing I have an algorithm that takes n cube time, that takes n square log n plus nm time, and n square m time. So we are going to follow an algorithm that is Floyd-Warshall, which is a generalization of the Dijkstra's algorithm that will also take n cube time, and that is also simpler to understand. सेम कंसेप्ट जो अभी तक यूज कर रहे थे, जहां पर कनेक्शंस नहीं है सेल्फ टू सेल्फ इट इज 0, एंड जहां कनेक्शंस नहीं है वहां पर इंफिनिटी किया वेट मैट्रिक्स से, पर जहां पर भी कनेक्शंस है डायरेक्टली इट इज whatever the value is there on the edge that we are putting in the matrix. So this is a weight matrix connecting each to each vertex. What we are doing here is we are checking for all the intermediate vertices. So if I have m vertices and there will be m minus 1 vertices, m minus 1 intermediate vertices, तो हर बार एक initial matrix बनी, next matrix में हम vertex 1 को intermediate consider करके we are trying to change the values. In the next matrix, vertex 2 we will consider as intermediate, and so on. How many such matrices will be made for the solution? There are m vertices. Yes, anyone answered? Please be loud. मैंने क्या बोला, एक मैट्रिक्स में इनिशियलाइज कर रहे हैं, नेक्स्ट मैट्रिक्स होगी जब मैंने वर्टेक्स 1 को एज इंटरमीडिएट लिया, the second matrix is when I am taking vertex 2 as intermediate, and so on. I am taking each vertex as intermediate ones. So how many such matrices will be there? M minus 2. Why? नहीं, last destination है ही नहीं यहाँ पे. We are, this is all pair shortest path. This is not from source to destination. Each to each है. So as I mentioned, मुझे हर एक vertex को एक बार intermediate consider करना है. तो कितनी matrices आएंगी? -1 अभी भी m minus 1 है. m plus 1 है. Initially there is a initial weight matrix. एक एक intermediate consider करते हुए नई matrix बन रही है. So 5 nodes, 5 vertices को एक एक बार intermediate consider करेंगे तो 5 नई matrices बनी और एक initial थी, right? So this is what we'll be doing every time. अगर intermediate नहीं है वो matrix, sorry वो vertex in the path, so the cost will remain the same. If it is intermediate, then I am comparing ik और kj की distance का sum. If it is lesser than ij की direct distance, I'll consider that intermediate vertex and modify the cost. यही करते हैं अभी तक graphs में. Let us say the graph that we considered in the Dijkstra's. Sorry. We'll take example here only. Let us take this example directly and then I'll come to the algorithm. यहाँ पर पहली matrix, we are labeling this matrix as distance matrix and ऊपर subscript will be 0. That is the initial weight matrix. So self के लिए the cost is 0. जहां पर भी edges पे cost है that those have been labeled, and wherever connections are not there, those have been labeled as infinity. Simple initialization. So again, you are either given the graph in the exam or you are given the matrix in the exam. 3 vertices are there. So kitni nayi matrices banengi at each iteration? How many total matrices will be there? 4. Take initial and 1 means 1 को intermediate consider किया है, 2 means 2 को intermediate consider किया, 3 means 3 को intermediate consider किया. So let us consider this initial matrix and now let us take vertex 1 as intermediate. So where will the change happen? Via 1 किसकी cost change हो जाएगी? तो हम क्या नहीं चेक करेंगे? We will not check for the first row and for the first column. Are you getting this thing? उतनी computations में reduce हो गए क्योंकि 1 to 2 की cost कैसे split करें? 1 to 1 plus 1 to 2. That does not make any sense. 2 to 1 की cost will not change because 2 to 1 को कैसे split करें? 2 to 1 and 1 to 1. That does not make any sense. So we only need to make comparisons where 2 to 1 plus 1 to 2. Am I getting a lesser cost? लेकिन यहाँ पर less होने का कोई मतलब नहीं है because there is no connection over here. So we are not checking the diagonals as well. What do I need to check now is 2 3. तो 2 3 को क्या check करना है? 2 1 plus 1 3. Are you getting a better path? Is the cost getting reduced? We are getting a path, but the cost is not lesser, right? We will check again for this value, that is 3 to 2. So 3 to 1 and 1 to 2, are we getting a better path? 3 to 1, which is 6 plus 4, that is 10. So this is what it was mentioned here. कि मिनिमम हम किसका देख रहे हैं? प्रीवियस इटरेशन, मतलब कि प्रीवियस मैट्रिक्स में, दैट इज k minus 1th इटरेशन d of 0, d1 के लिए d0 मैट्रिक्स में देख रहे हैं i j की डायरेक्ट डिस्टेंस या फिर प्रीवियस मैट्रिक्स से ही हमें कॉस्ट मिल रही है i k एंड k j का एडिशन. दोनों में से whichever is minimum, I'll update accordingly. Right? Let us take this example ahead. Now take vertex 2 as intermediate. कौन सी cells को we will check and which cells we should ignore. कौन सी रो को नहीं चेक करने की जरूरत है? diagonal elements को नहीं चेक करना. और which row and which column? Second row and second column. I again repeat why. Because 2 से 1 के लिए अगर 2 को intermediate लोगे, so how will the split happen? 2,2 plus 2,1. 2,2 is anyways 0. So 2,1 remains 2,1. Similarly, अगर 1,2 की बात करें उस column की, so 1,2 को कैसे split करोगे? 1,2 plus 2,2. So again 2,2 is 0. So there is no sense of checking the same row, same column and the diagonal. तो कौन सी दो cells को check करना है इस matrix में? Online people. 1, 3 and 3, 1. तो क्या चेक करेंगे? 1 2 2 3 का 1 2 and 2 3 6 और 1 3 डायरेक्टली कितना था? 7. So that gets changed. Now let us talk about 3 1. 3 2 2 1. Three 2 is infinity from the matrix, so directly वो infinity बना देगा. So this is done. Now let us talk about the third vertex as intermediate. तो यहाँ पे and please remember every time we are making change to the new matrix that is being formed, right? Because इस recurrence में for kth iteration we are making changes or taking the data from k minus 1th integration. People make a mistake कि original matrix initial matrix में changes करते हैं. Yes. What about this? कौन सा row और कौन सा column नहीं touch होगा? I need this answer from online students. Which row and which column you need not check out? नहीं आ रहा उधर से reply. हाँ तुम लोग बोलो third row and third row. And the diagonal we are leaving. So which elements we need to check? 1, 2 and 2, 1. So अभी check करेंगे 1, 3 और 3, 1. Sorry, 1, 2. 1, 3 and 3, 2. Will not change. 3, 2 and 2, 1. Will not change. So that is why you can see that D superscript 2 and D superscript 3 are exactly the same matrices. But we have to iterate over because our algorithm has been designed such. So now let us move to the algorithm. So again in the algorithm, if I and j are same, then D0 matrix is initialized as 0. If ij is in edge, then I put ij के accordance में I put the weight of that edge in the matrix. Otherwise, the remaining cells are initialized as 0. So initialization हो गया. Question to you people. K I J ऐसा क्यों लिया हुआ है nesting? Why not I J K? Remember, this is something अगर matrix multiplication याद होगा किसी को? So matrix multiplication loops are not I J K. How are they? नहीं याद है. So here, when you are iterating over the rows and columns keep changing accordingly. Cells are changing, but the intermediate vertex remains fixed for that iteration. So intermediate vertex की एक matrix के लिए वो fixed है. The next iteration में it is fixed. लेकिन उस जब vertex को choose कर लिया intermediate, then we have to check for all the possible rows and column combinations, right? So that is why you have to remember this K and then I and J. So again, with respect to the time taken, because 3 loops say for the time taken will be NQ. So how can we reduce down this time taken as it is mentioned in the slide? अगर हम single dimension, अगर हम 2D array लेते हैं तो time can be reduced down to n square. 2D array में कैसे store करेंगे? मुझे तो ये storage matrix में ही चाहिए ना. How will I use 2D array for storing this? हाँ तो सबने बोला जब मैंने बोला कि 2D array यूज करेंगे. Online people, if you're not answering to attendance mark, it's okay, it's better to leave. My question is, how can we implement the same using 2D array instead of a matrix? Anyone answering? Matrix को array में ले सकते हैं ना, one after the other, row by row, right? Yes or no? So again, a question on this. As I mentioned, you could be given a graph or you could directly be given a matrix. So you can practice this out. And then please again follow the deadline to submit on GCF. So next turn we are completing these 2 topics, that is 0-1 knapsack, traveling salesman problem and longest common subsequence. Again LCS is easy, but these 2 take time to understand. Thank you all. The attendance has been taken. You people can leave the meeting. And whosoever would have missed the FA, sometime later, I will open the link and get it.
Thank you, ma'am.